Hi everyone, I'm Mr. Faulkner. Today, Mr. Cook and I have a science challenge for you to measure the speed of light using standing waves. Now, what are standing waves, I hear you ask? I'll pass over to Mr. Cook, who will talk you through them.
A standing wave is the sort of wave you get when you pluck a guitar string. Unlike sound waves or ripples on a pond, a standing wave does not transfer energy from one point in space to another. It simply stands still, hence the name. A standing wave can be formed when a progressive wave is reflected by a boundary. The reflected wave then interferes with the progressive wave and a standing wave is formed. You can try to make a wave like this at home. All you need is a piece of string and an electric toothbrush.
So if you want to measure the speed of light at home, what we need to use is our microwave. As we know, microwaves are a type of electromagnetic radiation, or in other words, just light radiation. So if we've got a microwave that's giving out all of those microwaves, sending them one way, reflecting the other way, a standing wave will form just like Mr. Cook has just explained. What we can do is find out two things about our standing wave in that microwave to then be able to calculate the wave speed. The two things we need to know are the frequency and the wavelength. Frequency f, wavelength lambda, to then be able to calculate the speed. To do that, what we need to find out is where our microwave gets a bit hotter and where our microwave doesn't get as hot. And the reason for that is the places where the microwave gets hottest, those places are the so-called antinodes of our standing wave. And you can see on this diagram what those antinodes are and what they look like. Because that is where the highest vibration happens, that is where most of the energy of the wave will transfer. So that's the place where our food will get the hottest first. Obviously, do ask your parents before you do this, if you are planning on doing this yourself. Take all of the parts out, including the wheels, and if you've got this, a little grip that holds onto the turntable. Then you need a plate, which is, please make sure that it's a microwave safe plate. And you need to get a bit of food that you've got on the plate. Make sure that they're not touching, if that's at all possible. I'm going to stick this in a microwave on 15 seconds on maximum power. This will help us find out the wavelength. How can we find out the frequency? Much easier, just check the back of your microwave or check the manual. If you can't find any frequency on your microwave, use 2450 megahertz. So, if we have a look then at the food, at the marshmallows, we can quite clearly see that some of these marshmallows have molten quite badly and some of them are still normal. So we need to measure the wavelength. We need to measure from one collapse, one area where it's molten quite heavily, not to the next one, but to one further. So make sure that you measure two. If I measure this quite quickly, roughly about 15 centimeters. So just use your normal ruler, roughly about 15 centimeters. Then we can use that same equation, V equals F lambda, to calculate the speed. V equals F lambda. We now know that our wavelength is 15 centimeters, or 0.15 meters. Our frequency, 2450 megahertz, or million hertz, so that is 2450 with an extra 6 zeros. Hertz. And when we calculate that, I found that my speed of light is approximately 400 million meters per second. As we know, speed of light about 300 million meters per second, so my measurement is quite close. It's in the same order of magnitude, the same number of zeros, so I'm pretty happy with that. Now, what I want to challenge you guys to do is to find out if you can do this same thing, recreate this experiment, but find a better value for the speed of light. If you can, make sure you send us a video or send us your results of your practical, and I'm really excited to see what you guys can do and how accurate you can make your own measurements. So good luck, and let us know what you find out. Thanks guys, and thank you for watching.